Imagine spending decades searching for a missing piece of the universe. A piece so important that without it, our entire cosmic puzzle doesn't make sense. That's exactly what scientists just did. And the results are surprising. Deep underground in South Dakota, almost a mile beneath the surface, sits one of the most sensitive physics experiments ever built. It's called LUX-ZEPLIN, or LZ for short. And recently, it finished a record-breaking investigation into two of the strangest things in physics, dark matter and solar neutrinos. Now, here's the twist. The experiment didn't find dark matter, but what it did reveal may change how we search for it forever. For decades, scientists have believed that most of the matter in the universe, around 85%, is something invisible and unknown. We call it dark matter. One of the top candidates for this mysterious substance is a type of particle called a WIMP, or weakly interacting massive particle. These particles barely interact with anything, making them almost impossible to detect. That's why researchers built LZ, a huge chamber filled with 10 tons of liquid xenon, cooled and shielded from cosmic rays by being buried underground. If a WIMP crashes into a xenon atom even once, it can create a tiny flash of light, a signature scientists know how to spot. So after collecting the largest dataset ever, did they finally catch one? Not exactly. The good news is that the experiment did see something else: solar neutrinos, ghost-like particles constantly streaming from the sun. These particles barely interact with matter, so spotting them is incredibly rare. LZ detected a type called boron-8 neutrinos, and scientists reached a 4.5 sigma confidence level, extremely close to the gold standard 5 sigma discovery threshold. Why does this matter? Because detecting neutrinos helps scientists rule out false alarms when searching for dark matter. It's like learning what the background noise sounds like so you can finally hear the real signal. Even though the experiment didn't find WIMPs, it narrowed down their possible properties more than ever before, tightening the net around dark matter. For the dark matter search, the team didn't see that unmistakable, coherent nuclear recoil, the signature they would expect if a WIMP collided with a xenon nucleus. And strangely enough, that's still progress, because in science, even a negative result tells you where not to look next. Rick Geitskell, one of the leaders on the project, summed it up perfectly. Don't assume nature works the way you think it should. Some theories that once seemed beautiful and elegant, nature simply ignored them. But the hunt is far from over. In 2028, LZ will begin its next run, a massive 1,000-day experiment, the longest ever attempted. The detector will again look for WIMPs, for solar neutrinos, and even for completely new physics beyond the standard model. And who knows? Maybe the universe really is hiding its missing piece just one interaction away. Because discovering dark matter won't just solve a scientific mystery, it will reshape our understanding of reality itself.